up next, we are going to be creating a rotated plane, but this time it's going to be off of the new oblique curve that we've created in space, which would be this one right here. Okay, which is also this one right here. So think back to what I was just telling you in the previous video about cleaning up the lines and the connections. If all of this script right here, this string of information, is predicated upon one particular reference line and there are 5 different connections, I want to probably just prepare ahead of time for that connection. So I'm actually going to make an output wireless connection right off of that curve right now. Because I know that if I'm going to build something off of it and it functions exactly like this one, that I pretty much know that I'm going to just use that curve for all the connections. So I can go to line. This one? Yeah. So line or curve, actually both will work. And you plug that in and call this one, I'm going to call this OBL curve for oblique curve. I'll call it oblique curve 1. And like I said, every time you do this, make 2 and connect them. That way you can trace. The reason I say make 2 is because you're going to leave one here and you're going to move the rest somewhere else. Okay, so this one stays connected to that, so you can read, right? These should say exactly the same thing. Oblique curve 1, oblique curve 1. This is going to move down here. Okay, so I moved it down to the bottom left corner because what I'm going to do is take this entire chunk and move it down, right? Nothing is changing except for a couple of little things that I need to do to get it to speak to a curve that's in a different orientation. Is that clear? Does anybody need me to state that again for a little bit of clarity? Well, I'll state it again anyway. We're moving the whole thing down because nothing about what we did here is going to change except how we want this idea to reference the original geometry in a different orientation, right? So there are differences. The first one we assumed was always going to be on the base plane. This one is not on the base plane, so we have a couple of just very minor differences to do, mostly around here, how everything starts plugging in. But largely it'll be a lot of the same stuff. So to get us going, I will copy this entire block and paste and pull it down right here. All right. So one of the first things I'm going to do here is replace my connections to the base curve with my new curve. Okay, so no longer am I going to be referencing in the bottom one base curve. I'm now referencing oblique curve 1. So I can just go through and switch them all out. These are all manual. And I'll make a copy of that and move it up here. Disconnect base curve, insert oblique curve 1. Disconnect base curve, bring in oblique curve 1. Okay, so you can already see the relationship forming, right? Now we have a curve that we can rotate, change the amplitude, change the angle, of the other edge. Trying to think through here what I did differently. Oh yes, that's right. So the thing that threw me off when I was initially going through this is that, yeah, I can do all those things and it looks good. It looks pretty great, in fact. But what I want is a measure of exactness. So I don't want to say, if you're looking at the way that this is right here, and I change my rotation to 0, what do you notice? Right, I changed my rotation to 0. So what I'm thinking is, if my rotation angle is 0, it should be perpendicular to this plane, because I want it to be exact. If I say that I'm going negative 15 degrees in one direction or positive 15 degrees in the other direction, I want that to be negative 15 degrees from the perpendicular angle of that plane. But when I plugged in the new definition to the previous reference geometry, it did this. If you look at the base plane, you see that the y-axis, right, the green axis, is misaligned to the original surface. So, wait a minute.
It's kind of like you change the base.
Yes.
With OBL.
Yeah, so I created the OBL curve here and made the wireless connection just like I did before. Pulled it down and replaced all of the connections along here. It's exactly the same. The only thing I've done so far is replace the connections with oblique curve 1. Does anybody else need me to pause for a second here in the explanation? Okay. All right, so our trouble here is this plane. If you happen to have your first rotation set to 0, you won't see it, because it's going to appear as if it's in line with the plane. Actually, mine looks slightly off. Oh, just because of the angle. But if you look at it head on, it's going to appear as if it's aligned with the plane. But as you rotate out of plane, you notice that it still keeps a relationship to the XY orientation. So we have to change that if we want our angle to be exact and referential to the orientation of our first plane. Does that make sense? Do I need to clarify what that means? Okay. So as it stays, it's kind of like saying this, right? So I've got this thing, and I want to rotate it. I think it's like a carnival thing, right? You know that thing that kind of like shoots you around like this, but it stays like horizontal the whole time, right? Well, this plane is going to stay horizontal as it rotates down, right? Stays horizontal, stays horizontal, stays horizontal, all the way around, wherever you're taking it. So what we need to do is map this thing so that as I rotate it, it's going to change in orientation rather than staying horizontal. Does that make sense? Okay. Huh? No. That won't be on the video, but maybe I can pull up that thing. So, Carnival Ride. Anybody know what they're called? No. It's
No idea.
not that. It's like this, except the body of it stays horizontal.
I think I know, but I don't know.
One in London is a little bit like that. One in central
No.
London.
A carousel.
No, it's not a carousel. Darn.
The old one is kind of like just going.
I thought it was like a standard Carnival Ride, but I guess not. All right, anyway, we're wasting time on the video. So you get the picture, right? This thing is going to try to stay horizontal, or at least referential to horizontal, unless we tell it otherwise. So this or that, or, oh, sorry, this one. That happens to be the plane, right? So this is the new plane that is referential to the surface, just like this plane was referential to the first surface. This one builds the second surface. So notice how if I rotate the angle of the second surface, right, it kind of falls off of the 0 plane there, right? So that's the same problem we're having. We are going to rotate this plane the same number of degrees that we've rotated the first plane out of perpendicular. Does that make sense? So it's just going to be an inverse relationship, so it matches up. And to do that, let me just find where the connection was again. Ah, yes. So to do that, right, when we're changing that rotation, it happens. Is it this one? No, I think it's this one. Nope, that's amplitude. Sorry. Yeah, this one. All right, so this is the angle that I'm going to emulate. And so I can create a rotator for it just by dropping in. This time we're going to have to do a planar rotate because it's going to stay in the orientation that it's in. So I'm going to say under transform Euclidean, I'm going to do rotate, the one with the plane on it. And I'm going to put it somewhere down here. Let me move this out of the way. Whoops. So this rotate, we're obviously going to rotate this plane. Right now it looks all crazy and out there somewhere. But we're going to rotate it around, we're rotating it around its own base point. That's right. Which is kind of a weird little conundrum we find ourselves in. Basically, we want it to stay in the same location it's in, but we want it to just change its position, rotational position, orientation. So then we just drop in the same kind of stuff that we use for any of our rotates, except we're pretty much going to make sure that it's connected to the same number. So if it changes, it'll track all the way down. So this time, we're actually going to go up into params and go into, under primitive, there's the one that's just called number, not integer. Integer are full numbers, whole numbers. We want number. And we can plug in that degree value from the first, and it's right here, right? So it's this degree value from the first rotation. And I will call this brought 1, rotation 1. Same wireless connection now, right? So I'm feeding that one in. I'm going to create a wireless connection. And that one I will take down all the way down here to the corner. Yeah, will that work? Yeah. No. Yeah, it did. Okay, so here's the original plane, right? It's out of sync. And then if I turn that off, here's the new plane. If I look at it aligned, it shows that it has rotated it the same number of degrees as the original rotation. Is that clear? So I didn't do much, guys. I didn't do much. All I did, to recap, oh, and sorry, we can feed that back into the deconstruction of the plane. That was the last step, sorry. That's the one that's actually going to take that plane and reorient it so that your 0, if I set this to 0, so now it's a perfect 90-degree fold between the two planes. Okay, so all I did was add these two things and replaced the connection from this perpendicular frame to the deconstruct plane. It was a very, very minor edit just to get it to be a perpendicular datum line. So what questions do you have about that?
Did you copy?
This?
Yeah, this one you did, but the other one, the rotate axis.
This one I dropped in. It wasn't a copy. So it's exactly the same thing here, except I added in right here on the second one in that location, I added in these two components.
Oh, you bring it all the way down. Why you bring it all the way down? You move it for.
Why did I do this? Why did I do that connection? Is that your question?
Can you zoom in?
Yeah, I can. So I chose that connection because it has the same numerical value as my first rotation, because that was the problem. The problem was with this being my base point. Turn this one off. With that being my base point, that meant that call my rotation 5 degrees. Nothing. So if I have this is the original connection right here, from this one to the other one. Let's say I rotated it 5 degrees. That means that right here, Nafi, I want to make sure you understand this. Right here, that means that if I rotated it 5 degrees, that there's a 5-degree difference between the plane that gets mapped for surface 2 and the original surface, because it has a relationship to the original base plane xy. So if I take that 5-degree rotation, which is up here, and create a connection that brings it all the way down here to a rotator that says rotate 5 degrees, and I rotate the plane, if I rotate that existing plane, what it gives me is a rotated plane that is then aligned, closes the gap of that 5 degrees, and it aligns it to that surface. The reason being that when I connect that to my deconstruct plane, now that axis that I'm pulling information off of, my amplitude, is at the 0 value 90 degrees from the first surface. Is that clear? No?
Why you did that?
Why was it necessary to do that? So it was a decision of mine to do it, because I wanted all of my zeros to be orthogonal to one another. So basically, it's like me saying, I want to look at this piece of paper and fold it a bunch of different ways. And my basis point for all of my folds is going to be 90 degrees. So I fold it, and this is kind of a bad fold, but call that 90 degrees, right? So as I'm designing this building, and I have one fold that's exactly 90 degrees, I say to myself as a designer, all of my folds, I want to take them out of the 90-degree plane, but they can be no more or no less than 15 degrees off plane. Does that make sense? So it means I've set my design parameters to say it can go 15 degrees up or 15 degrees down. No more, no less. However, when I do this here, if I take my first plane, this one right here, and I put it off plane, then the new reference that it creates is has a relationship to the xy until I tell it to have a relationship to the first surface instead, which is what I did. So I re-rotated it so that the 90 degrees, even when it's tilted, references the first plane. Did I lose you?
Can I see what you added up top, the first row one?
I'm sorry?
The first row one, where you have it streaming from? Yeah.
I didn't add anything up there.
I think you looked at the block length ratings.
There you go.
So yeah, it's this one. I plugged that in because this value is my rotation. Goes all the way down here, and I rotate the base plane. Okay, so I'm going to close the video here. It's getting a little long, but basically now, if you look at this thing, we have the opportunity. I'm going to start from the beginning. I can change the height. I can change the angle that first plane is folded. Right, I can go down or up. I can change the degree of the actual end value of that surface. And then I can go to the next one and do the same thing. I can change how far it extends. I can go really far, or I can go really shallow. I can change the degree of rotation, positive or negative 15 degrees. I'll keep it somewhere in between. And then I can change the angle of this surface as well. So I can go long or I can go short. Are there any other questions? Okay, so our next step is going to be finishing off the actual form, and I'll explain with that one when we get started on the next video.